directions for problems 3 and 4 tell you to examine each sequence of pictures, write a numeric sequence to match the number of squares in the sequence of pictures, and then write an expression that could be used to find the number of squares in any figure number n. So we have figure 1, 2, 3. We could draw figure 4 and 5, but it would take quite a bit of time. But ultimately we're trying to figure out how many squares would be in figure n, which is just a variable, just any numbered figure, like figure 10, figure 11, figure 200. Once we know the rule, we could figure that out. If it's helpful for you to make a table, oops, not like that. If you find it helpful to make a table similar to the ones in problems 1 and 2, you can. I'll show you both ways. You don't need a table necessarily. But this is just like problems 1 and 2. You have some position in the sequence n, and then you have the term, which in this case would be the number of squares. So for example, when n is 1, for figure 1 we have 1, 2, 3, 4, 5 squares. When n is 2, figure number 2, we have, well, I see the same 5 squares as I had over there, plus these 4 on the end diagonal, so 5 and 4 is 9. For figure 3, we have the same as figure 2, but with 4 extra on the end. I think you can sort of see the pattern. It's plus 4 each time. So we indicate that this way. If the sequence is increasing by 4 each time, it's an arithmetic sequence. And for any number n, we can start the rule with that it's called a common difference, that number multiplied by n, 4n. But then, you know, sometimes that's the whole rule, and sometimes there's something you need to add or subtract from that. If you look at when n is 1, when n equals 1, what would 4n be? What is 4n? Well, it's 4 times 1, which is 4. But we have, when n equals 1, we have 5 squares in the figure. So we need to add 1 to this to make it 5. And so the rule is 4n plus 1 for any figure number n. And you can check that by taking some other number n, like 3. n equals 3. And let's substitute it into this rule, 4n plus 1. 4 multiplied by 3 plus 1 would be 12 plus 1, which is 13. And that is the number of boxes, or the number of squares in figure 3. I mean, 9 plus 4 is 13. Also want to look at problem number 6 with you. This asks us to write an equation that describes the sequence, then find the indicated term. This is just like the other problems, except you don't have a table. So if it helps you, just understand that this is the first term in the sequence, so n equals 1 for this term, 2 for this term because it's the second number in the sequence, 3 for this term, 4 for this term. Or if the tables really help you, you could make a table to make it more like the other problems. The terms in the sequence as given are 6, 17, 28, and 39, and those represent the first, second, third, and fourth positions in the sequence. Now think about how is the sequence changing each time, and try to use that to write a rule. Do that during the pause and come back and see how you did.
Paused.
if I'm going from 6 to 17, I'm increasing by 11. And then 17 plus 11 is 28. 28 plus 11 is 39. So when we start to write this rule, we take this common difference 11 and multiply it by n. This would be the rule for any number in the sequence n. But then we have to check it for, let's just check it for n equals 1. 11n would be 11 multiplied by 1, which is 11, but we don't have 11, we have 6, we have less than 11. We have to take something away from 11 to get the 6 that we need. What would you take away from 11 that would give you 6? You would take away 5. So subtract 5 in the rule, and then we should have the rule that works for any number n. But we'll test it. Let's try for when n equals 2. 11n minus 5. So 11 multiplied by 2 minus 5 would be 22 minus 5. And that is 17, which is what we expected it to be. So we know, once we've done that, we know our rule is good. 11n minus 5 is the rule. Since it asks us to write an equation, we should really say t, the term, equals 11n minus 5. But then it also asks us to find the indicated term, in this case the 12th term. So we just need to substitute 12 for n into our rule. 11n minus 5. When n equals 12, it will be 11 multiplied by 12 minus 5. 11 times 12 is 132. And if you subtract 5 from 132, you get 127. So the second part to this question is 127. Okay, I hope that helped with the homework. I'll see you in the morning.